Good evening, everyone. So today we'll learn how to build a buzzer symphony using hand gestures. And this would be achieved by linking image processing libraries with IoT. So let me start with my introduction. I'm Apurva Kulpe, a third year BTech student studying in VGTI and pursuing a degree in electrical engineering. I'm also well versed with programming languages like Python, C++, JS, and many more. Okay, so let us start with the objectives. Firstly, I'll just give a short introduction about what we're gonna learn today. Then I will explain the hardware connections, and then in the end, I will explain the code and demonstrate the entire project. So the basic idea behind this project is to control a buzzer's volume using hand gestures. For this, we'll find the distance between the tip of a thumb and the tip of index finger, and this would be displayed in front of a camera. And to do this, we'll be using an image processing library called MediaPipe. And I would say further about this in later slides. And then we would calibrate the length, that is the distance between tip of the thumb and tip of index finger, with the pitch of the buzzer accordingly, so that we could get that buzzer symphony. As mentioned before, the framework we'll be using here for detection of a hand is MediaPipe. MediaPipe offers ready-to-use yet customizable Python solutions, which is nothing but ML libraries which are in pre-built Python packages. It has several solutions, and I have mentioned a few here that are face detection, hand detection, pose detection. There is also auto flip, cropping, automations, etc. in MediaPipe, which if you are interested in this, you can visit the MediaPipe website and learn more about it. The model we'll be using here is called hand tracking module. This uses two main modules at the back end. One of them is the palm detection and the other is hand landmarks. The palm detection just detects the palm and provides a cropped image of it, as you can see in the image shown here. And then the hand landmark module finds and marks 21 landmarks as shown in the image. Today, we will just need tip of the thumb, that is ID number 4, and tip of index finger, which is ID number 8. So let us get into the hardware connections. The hardware connections are simple. You'll just need a buzzer and bolt Wi-Fi module. Also, if you want more stability, you can use breadboard for connections of wire and buzzer as shown in the image below. So you'll just connect the positive terminal to pin 0 of your bolt Wi-Fi module. You can also use digital pin 1, 2, 1, 2, 4, any if you want, but I'm using pin 0. And the negative end of the buzzer would be connected to the ground. So let us get into the code. So firstly, you will just have to install two packages, which is OpenCV library for image processing purposes and MediaPipe. For that, you would just have to, for now, I'm using Spider console, but if you have PyCharm or Jupyter Notebook, you can use that as well. So to install OpenCV, you just have to do pip install CV2 or OpenCV, whichever is suitable for your software. And then also you have to install MediaPipe as well. I have installed both, so I don't have to do it again. So firstly, I'll just show how to run the captured video. So for that, you'll just have to import CV2 profile. And now you would create a video object. So this CV2 is an image processing libraries in which you can just create images and edit them or maybe mask them, and it's just like like a more complex version of Photoshop, you can see. So firstly, we would create a video object. For that, you would do cv2.video capture. Now you have to insert a parameter. I'm using my webcam number 0. So I have inserted 0. Now you could have more than one webcams, and then ID would differ. You can have webcam number 1. And in this video capture, you can also play an already recorded video. You'll just have to insert the link of the video in single quotation marks or double quotation marks. For now, I will just use my webcam as I need it. And now we would start an infinite while loop, which would be achieved by doing while true. Now we are using while loop because a video is just collection of infinite images. So the while loop is just recording the frame rate by rate. And that's why to play the video, we need an infinite while loop. So the frames are played in like a video form. So firstly, we would need two variables, ret and frame. You can declare anything you want. It's not necessary to use the same variables. So firstly, we would do cap.read. As you can see, there are instructions given here as well. What it returns. It returns the next video frame. So that's why we need a while loop, because at a time it's just recording one frame and you would need multiple frames for looping the video. The ret is just a boolean variable, which would just provide, which is always true in this case. If it's false, then that means the video is hanged or stopped, or if there is any difficulty with your webcam and it's not displaying anything. So I would do cv2.imshow to display the frame. Now we can just end. We cannot just end here, because first we'll have to do some important parts where I'll have to declare one variable k, which gives a cv2.wait key. So wait key just gives a delay, and the parameters inside is measured in seconds. So for now, I'm just giving a delay of 1 second. So now I'm using k equals to 27, which is an ASCII value of escape button, so that once I press escape button, it breaks the loop. If I do not mention this, then the video would not close. And I'll show you this. Just wait a minute. Now first, now cap.release and cv2.destroy all windows is also important, because once escape button is pressed, it goes out of the loop, and cap.release just turns off your webcam, and cv2.destroy all windows just clears all the destroys the last frame, which is the frame on which you would be the video is playing. So let me just run this code. So I hope you guys can see this window here. Can you guys see this window? Just a minute. I'll just share my whole screen. So I hope you guys can see the window now. Okay, so this is what, uh, so now when I press escape button, so see, when I press this cross button, it just creates a new frame, because I have given escape button the value to escape this while loop. So once I press this escape button, it just closes the window. But if I press the cross on that frame, it doesn't closes the window, and it just creates a new frame because of infinite while loop. Okay, now let's get into the image processing part. For that, you would need media pipe. So firstly, just import media pipe file. Now you need the hand detection, specifically need the hand detection module of the media pipe. So for that, you just create a new object. So this is just like a basic formality, so that the system knows that we are using the hand tracking module. And then we would create another object for detection of hands, which is mp hands dot hands. To know more about this library, you can just control and click this library. I don't know why this is not showing up. But if you control click this library, you will just get a lot of media pipe features in which there is a detailed explanation of every point, has 0 to 21 coordinates. Also, there are a lot of variables for detection of hand. Now this hand variable that we created needs RGB image, but OpenCV only provides a BGR image. So first we will have to convert the image, the frame which we have created here, from BGR to RGB. So for that we create a new variable, and in that we just input our syntax CVT color. So CV2.color BGR to RGB just converts the BGR image to RGB. Then we would just process this and then we would just process this new hand tracking to results, which would just track our hands and the position of the hand. So if I so if I run this, nothing would be new. So there is nothing in the console, but it's still tracking our hand. But since we have not given any other command, so it's not gonna draw or detect anything. So for that, we need the draw utilities of MediaPipe library. So for that, we just do mp.solutions.drawingutils. And then we would create an if statement for, so this is an important statement, as only if the hand is detected in the window shown, like in my webcam, so only then the next code should be proceeded, or else there should be no result. So the multi-hand landmarks would detect 21 points. So that's why I have created a for loop, so that the hand landmark, which would give the position of all those 21 points, would be looped in 21 times. So mp.draw landmarks would just show the points, the 21 points that I've shown before on the window. I'll just run the code. In this, you would need the parameter frame in which you are showing your hand, and then the hand landmarks. It is just showing an error. Okay, hand landmarks. Just some spelling errors, sorry. So now you can see all the 21 fonts. It's a little bit unstable, as you can see, since there is no green screen or any like white background behind me. If you have like a green screen or just a single colored background, then the detection would be more stable. For now, you can just view the all 21 different points here. Now you also need the line connections. So for that, you can either use the math library of Python, but for that, it would just be too complicated. So MediaPipe also has another function called hand connections, which would just provide the line connections, but so that it would connect all the 21 points, which I would show now. So now you can see the lines have connected all the dots, which is important as we need the distance between the tip of the index finger and also the tip of the thumb. So as we have detected the hand points, so now we also need the exact location of the point. So for that, it is already detected. We just have to write the code for it. So for in hand landmarks, the multi-hand landmarks not only detects the point, but also the location of it. We just need to access it. So for that, I would create another for loop in which I will access the ID. The IDs are the points which I have shown before in the slide, that it goes from 0 to 20. So before doing this, I'll just show you what exactly the hand landmarks look like. And they are in between the range 0 to 1, so they would be in decimal places. So in the console tab, you can see I've got XYZ coordinates. So for now, we don't need any three-dimensional image. So we are excluding the Z coordinate, but we are getting all X and Y coordinates, which are important now. But as you can see, you are not getting exactly at what point the coordinates are for, like for the tip of the thumb or tip of the index. So for that, you need ID. So if I do print ID and the coordinates, so now you are getting so the tip of the thumb's coordinate is 4. So you are getting the thumb's coordinates and also the index finger's coordinates. But you need it in pixel format, and now you're just getting it in decimal form. So to convert it into pixel format, this is just the decimal part is just the ratio of the pixel to the entire size of the frame, that the window that you can see after running the code. So to get the exact pixel coordinates, you'll just have to get the height, width, and center of the frame, which you would get doing frame.shape. So this frame.shape is in CV2 file and not in MediaPipe. And then you would get the X and Y coordinates in pixel format. For that, you will have to do the X coordinate into the width, and for Y coordinate, you'll just have to multiply it with height. And I'm using int here, or so that I could just get a round off of it, or else it would just go to 9 or 10 decimal places. So as you can see in the console, you get the pixel positions of all the 21 hand coordinates every second. So for Buzzer Symphony, you have to you reuse this code all to be able to reuse this code. You can just create another module or class, which I have created here, and I have also mentioned a GitHub link which you would get here. So in this, you first have to declare the mode. The mode just basically tracks the hands, and if it's true, then it tracks the hand every second, which kind of slows down your frame rate, and the frame just lags a lot. So I would recommend the mode to be false. And then the self it's just like the self dot mode equals to mode is it just gives the variable. It's like the object has its own variable. So mode is an object, and its own variable is mode. So that's what self does. And the maximum hands, which I have set it default as 2. The detection confidence and tracking confidence, these are the main part. The detection confidence is 50. I have set it to 50%. You can change this to 70% or 80% for better accuracy. Same you could do with tracking. And again, we would just import the mp.hand solutions. We would just track our hands, which I have shown before. And then you would create 2 functions, one for finding the hand and other for the position of hand. And this we would use for a Buzzer Symphony module. So let's get started with the Buzzer Symphony. So firstly, you would have to import CV2 file and the hand detection module, which has the media pipe file. So because hand detect module, as I have imported here in line number 3, has media pipe file, I don't have to import it again here. Also, you would need NumPy and math for some basic calculations, which I'll show later. And then you'll have to import the Bolt module to connect a Bolt Wi-Fi module with our code. And also I have imported my config file, which has my Bolt API credentials and device ID. And I have imported this in file number 8. So firstly, we would just create an object, hand detectors. So we are calling the class which I have created in hand detect, the hand detector class. And then I have set the detection count to 0.7. If you want all the default settings, then you can just leave it blank. But since I want the detection confidence to be more accurate, so I have just added it right now. Again, you'll just capture the video for the web for detection. And now the main part is here. After reading the frame, firstly, you'll need to find the hands. And now you need to detect the frame, but also I have done draw equals to false. So what exactly this does is, in the previous frames, you have seen all the lines and points drawn on my hand. But if you don't want those, you can just do draw equals to false, and it would just erase the hand. I'll show you. As you can see, the red dots and the green lines are not visible on my hand. So after detecting the hands, you can keep this as true. If I do this true, wait, so you can see all the red dots and the green lines. And if you don't want this, you can just keep draw equals to false. And then you also need the X and Y coordinates in pixel format. For that, I have already created a function called find position, which gets the X and Y coordinates, converts it into pixel, and also appends it in a list. And the list format is ID number, the X coordinate, and the Y coordinate. So after that, I'll have to create an if statement if the list is not empty. So this would run only when the hand is detected. If hand is not detected, nothing would run. So you will need first the tip of thumb's coordinate. So as you can see in the media pipe image, it was ID number 4. So you get thumb's X coordinate and thumb's Y coordinate. So that's so X coordinate is actually has the index of 1, and Y coordinate has index of 2. So that's why I've mentioned 1 and 2. Same for the tip of index finger. And then you would create a circle around those for a better visualization. So to create a circle, you just do cv2.circle, and then the parameter, which is frame, the coordinates, which is x1 and x2, the x and y coordinates, the radius. I have input 10. You can just do 5, 10, 20, whatever you like. And the BGR color. This is the hex code for pink color, I guess. And you can just input any color you like. I've just inputted this, and then lastly, you just do cv2.fill. You can either do cv2.filled or just do -1 to fill the circle. I'll just run the code. Yeah, as you can see, the circle, the pink circle you can see is filled. But if you do 1 or 2, then it would create a hollow circle of width of 2. So as you can see, I've just changed the thumb circle coordinate. So you can see it's a hollow circle with width of 2. So I'm just keeping it -1. If you want something else, you can just change the width from here. And then for better accuracy and visualization, I've also taken the midpoints between the distance of thumb and index finger. In that, I've just used basic math, where I have just divided the summation of x and y coordinates by 2. And I've also taken floor division of it so that I could get int value. And then I have just made a line. Same, you just need parameter of frame, the x and y coordinates, of both the ends, the color in hex code, and then the width of line. So if I make this like 10, see the width is increased. And if I make this 1, then the width would be decreased. See, you cannot even see the line. So accordingly, you can change this. And then you need to measure the distance between the tip of the finger and tip of the index finger and tip of the thumb. So for that, you use this math function, math.hyport, which just gives the distance between your x2 coordinate and x1 coordinate and y2 coordinate and y1 coordinate. So it just gives the distance. So it's just root under x2 minus x1 the whole square plus y2 minus y1 the whole square. So after finding the length, you need to build a volume bar, which you see in the left-hand corner below. So as you can see in the left-hand corner, you just see a green colored volume bar. So now we're going to create this. So the volume bars ratio should be in like calibration with our hand coordinates. So for that, we use interp function so that it takes the ratio of both the coordinates, the hand coordinates. So I have taken my hand range. It is 20 to 150. Your hand range would differ, so you change it accordingly. And then I have taken the the pixel in pixel format, the lowest bar, which is 40. So I am comparing my lowest value, which is 20 with 400 pixels, and then my highest value 150 with 150 pixels. For better visualization, I'll just show. So you can see at the lowest range, this is 400 pixels, and at top, this is 150 pixels. So when I'm going 20, which is my least value, it's just going at 400, which I've done in the code. And when I go at my highest value, it just goes to 150. And if I don't do this, so let me just remove this line. The line just goes up, further up out of the frame. So that's why we do the interp thing. Same now for the inner rectangle, which is going high and low, we have to match that rectangle's length with our buzzer frequency, and a buzzer frequency varies from 0 to 255. So for that, so my least hand range, which is 20, would be corresponding with 0, and my highest would be the highest frequency of the buzzer, which is 255. Now this is an extra step. If you don't want to do it, you can just skip it. But this just says that if my length is less than 20, so the color of my circle would change. And this kind of just gives a visualization that my buzzer should stop. So if I run the code, so if my length gets less than 20, its color changes, as you can see. So that's what the if statement does. It's not necessary. It just gives a visual effect that yes, the buzzer is off. And then once you interp this, you also need to create an CV2 rectangle, the rectangles that we have seen, with again the parameter using frame, the length of rectangle, and the color of rectangle you want, the BGR form, and also its width. In the second rectangle, you can see there is int volume bar. We have done this int volume bar so that it changes according to our hands, the distance length. So now you have set all the display of volume bar, as well as you have also got the distance of distance between the thumb and index finger. So now you would use those values with the buzzer's frequency. So for that, you just do mybolt.analog, right? As you need analog values for frequency of the buzzer. The pin number, in my case, it's 0, and then int volume. So the volume would convert this 20 to 150 range from 0 to 255 range. I'll just run this code and show you. So I hope you can hear the buzzer. And when I decrease my distance, the pitch gets decreased as well. And when I increase my distance, it just rings again. And when I do this, the buzzer is off. Now the frequency is changing because I have used an M key button, so that the frequency changes when I press the M key button. This is important because if I don't create this mode equals to true, which I have already declared here as well, which is equal to false. If I don't do this, then the buzzer would keep ringing continuously with the change in my the distance between the hand and the distance between the tip of my thumb and the finger. So for better stability, I have used the mode equals to true form, so that when I press my keyboard button M, only then the buzzer frequency would change. As you can see. See, if I'm increasing and decreasing, nothing is happening. Even when I press the M key, the value is set here. But if I'm increasing or decreasing, nothing's happening. But once I press M, the frequency changes. Also, in the end part, you have to write my bold or digital write low, so that even if you left the buzzer at higher frequency or any moderate frequency, once you close all the tabs, the buzzer would be off anyways. So that's all for today. Thank you.